When data is collected and analysed, it can typically be skewed in any number of ways, but a very common pattern that data tends to follow is that of something called the normal distribution. It looks like this. Other people call it a bell curve, or if you're really fancy, a Gaussian distribution. In the normal distribution, data tends to hang around a central value with no obvious bias to the left or right. On the x-axis are the values of the observations you take. These can be things such as errors in measurements, height of people, or marks on a test. The y-axis is simply the probability that an observation may take. The actual curve is created by taking the mean and standard deviation of the data and performing some magic on it. Standard deviations have a special relationship with normal distributions. With the standard deviation, we have a standard way of knowing what is normal and what isn't. If we juxtapose the standard deviation to the curve, we can show graphically where most of the data will lie. It is generally accepted that when calculating the standard deviation, we find that mostly 68% of the data lies within one standard deviation, 95% of the data lies within two standard deviations, and 99.7% of the data will lie between three standard deviations. You may have also heard of something called a z-score. A z-score is actually a measurement of how many standard deviations an observation is away from the average. But what does this all mean? I'll show you. Here is a curve I prepared earlier. It has a mean of 15 and a standard deviation of 3. Each purple line on the curve represents a whole standard deviation. So by that logic, a score of 12 or 18 would be one standard deviation away from the mean. To find a z-score, we use a formula that finds the difference from the mean and divides by the standard deviation. So a score of 19 in this particular curve has a z-score of 1.33 and is represented by the red line on the graph. The green lines on the graph are summary statistics. The lower quartile, median and upper quartile are shown where that particular value would lie. Knowing the median is useful as we can check if the data truly has a central tendency. This graph has the median equal to the mean, so this is an accurate representation of this set of data. The median doesn't always have to be exactly equal to the mean, but if the median is skewed too far away, then it can show that the data does not have central tendency. Lastly, if you can calculate the area under the curve, you will find that it is equal to the probability that a score will fall in that area. A score of 14.5 from the same curve will have a probability of being higher than 43% of all scores. This is because the area to the left of the score makes up 43% of all probabilities. This Windows application was created by me in C# and is free to download at the HawkerMaths website to assist in teaching and other uses.